Hey, everyone's being recorded, and we're going to talk about compilers, maybe, or yard weed whacking issues, or whether or not Levo's test case should have one or two branches, and whether or
Yeah,
not I
so
can break somebody else's compiler. That was all things we did this morning. There's the Godbolt link from Levo. That's actually a good opener. All right, I'm done with my spiel here. I'm going to hit the Godbolt link. I'm going to hit share. I'm going to ask Levo ask his question again here. This is surely the right link. Yeah, there it goes. What are we talking about, Levo? Something about one or two branches, and it was like micro optimizations. What's the question?
since both parameters are in resters, I was wondering, is it profitable to uh, use one branch instead of two when you have no profiling data?
You
Because to
have,
me, it sounds like you would want to minimize branches, but maybe it just doesn't matter. I have no idea.
yeah, if you don't have any profile data, it hardly matters. It's one of these deals where the x86, if any of these tests are predictable at all, on the second go around and after, he'll be fine. He'll just predict and life goes on. In various kinds of micro benchmarks, you can push the issue where he badly wants to have one versus two because he's out of branch predictions, or you're highly unpredictable and you want to have a conditional move or whatever. There are cases where it matters, but only like in tiny micro benchmarks. So out of context, I don't care. If you're doing the code generation for this, I'd take any of the above on the onesies and twosies here. GCC 13.2, Clang 18.1. ICC with his pushes and pops, I would like
Yeah.
eyeball sideways. Like, what the hell are you doing, dude?
Yeah, that's I noticed that right away and I was so confused.
Right. So for people looking here, I'm looking at the third column. I just highlighted it. There is a push. Okay, why? Um, Fine. He did it because he's going to call external function and he wanted a register, I guess. He didn't use RSI. Still confused. Why? There's no purpose for that. Test, jump, test. If you just skip the RSI, except maybe around the call to external function, no, there's no call for that. So if I go look over at GCC, he pushes and pops around the call to external function by subbing RSP, right? Now, why did he do that? I don't know. Probably some of his calling convention demanded a hole in the stack.
Were you talking about the right on line 31?
I was looking at on the right at line 3. The right one's
Oh,
called line
line
3. If I
3.
go down to line 31, I see some kind of crazy crap, but I didn't pay attention
Yeah,
to
that
it.
one makes more sense because he on 35 they do a read of it, and then on
Oh,
42 they do a pop of it.
well,
So
how did he get here? It's like, why did he push RSI? So the main path is, I would claim you would test EDI. So line 4, test EDI, jump to block 1.4, get out. Test ESI, which he's pushed. Oh, I see. And it's in an argument. And then get out. And then he calls and he gets out. Where is single branch? Oh, 2. Oh, I'm missing. I see. 1, 2, 3. Yeah, okay. So
See, my
he's
thought
yeah.
process was if they're both highly predictable, it would be bad if you're missing twice instead of once.
If
So
they're
I
both
thought maybe it should always be trying to merge it when it's like this simple. But none of the compilers do it, so I was a little surprised.
if it's highly predictable, the compilers
Yeah.
are fine leaving it alone.
But if it's
Yes, it's predictable.
unpredictable, and because when I say no profile data, I assume like a bad case, maybe not worse, but just like a bad case. And a bad case would be both of them, or at least one of them not being predictable. So I thought it would merge it, but
Um, I mean, I did this kind of stuff all the time for, oh, here's another person, Derek, shut up. C2, but I guess that was the one I worked the longest on. We didn't observe like screwing around for multiple Boolean tests. So you wrote C code. In Java, I get a lot of Boolean tests where somebody introduces a Boolean for no good reason because the Java language syntax demanded it. I wanted to test something against 0. I had to do = 0 question mark true : false or something stupid. I had to convert it. So I got a lot of these multiple tests of things. I did some work to and them together. I don't know that it paid off.
Okay.
I wouldn't have worried too much about this. If they're predictable, you do just something on the layout, especially if the first one is going to predict, then you don't even bother with the second one. You just do the layout so you fall through. In the absence of data, and I wouldn't have much data. I have data on the branch. No, I would have. You're right. I'd have. Oh, I wouldn't unless C1 did it. The interpreter will never give me that profile of detail because it didn't do basic blocks. The C1 profiling that I did at Azul would get me basic block level data, and I could decide to do something, but I would, long before I got to basic block layout, decide to fold them or not. And I quit doing effort there. I put a conditional move in, it might do something. I had some test things that said, you're anding a bunch of Booleans, I can and the results first and then test at the end. But no real effort made to decide to do this or not.
So if how is it really trivial to implement this kind of optimization, just to and them together when you can tell they're in registers?
In the sea of nodes, yeah. You get everything in just in nodes, and you have a pattern that says I have a Boolean producing value here and a Boolean producing value there, and I have a back-to-back conditional tests. I'll turn them into an AND function. I can do that. That's
By
not
the
hard.
way, try changing the and to a single ampersand on line 3 in the source code.
Right.
Yeah, I mean,
That's
like it's
interesting.
Can
the
I
thing is
do
though,
that?
Yeah. And
that would
watch
be
the
weird
branches.
though.
Because notice that now we are not asking for the short circuiting operation,
Right.
whereas when you use the double ampersand, you are explicitly asking, please make 2 branches, and I want the first branch to only test A, and only if the third branch has failed, then I want to have a second branch that is going to test B.
That's
This is
what,
basically the C standard basically requires the compiler to generate 2 branches when you use the
I
double
hear
ampersand.
you, and I tell you that in Java, I paid no never mind to that distinction, but I didn't make an effort to do much. So here he clearly uses two registers, EDI, ESI for the test. So yes, he did what you'd expect one branch. But I got a whole ton of things that were either single ands or double ands in Java, kind of arbitrarily, because you had to have double ands if you had a bool, if thing you knew was typed Boolean, like ints and bools couldn't
Yes.
be mixed.
The reason it's illegal in C++ or C to optimize double end is you may be testing pointer for null and dereferencing that pointer. So it is required to first have the test for the not null and only then dereference the pointer and maybe test it against the value against 0. But
So
you don't
I
want to
understand.
elide this.
I understand, and I'm trying to point out that in this case, because the B is a known single value, it is not a load of a memory. I know for a fact that it's available. I can reorder those expressions in any order. And that's available to me as a peephole transformation. Hey, I have 2 values in registers. Because it's SSA form, they're all in registers. The 2 in registers, I can do them in any order. Well,
Right, I think for this seems reasonable to me too. Yeah.
Now,
Yeah, I
if,
mean,
you know, if what you said was, if it was this, then obviously I can't, you know, whatever, I broke the program, fine.
Sure.
But you know, I totally agree. If there's a pointer there, there's something with side effects, I can't do that. I have to do it in order, absolutely. I got two integers in a register or 2 pointer, whatever, 2 things in a register, I claim you could, and I'm surprised that they don't, but I wouldn't claim it's a huge deal either, so.
Okay, so that's what I was looking for. If you were surprised that they don't or not.
Yeah,
I
I'm
don't wanna-
surprised that they don't, but I'm also claiming that's not a giant thing. There are
Okay,
cases
yeah.
where you can make it bigger in effect, but it's mostly. Eh. All right, any more questions on this before we abort and claim we're out of topics?
Just out of curiosity, I'm not good at x86. So what would the assembly look like if we want to have no branch, like only a single branch? And
I'm going
we
to take
got the
this and
clashes?
on line 3 on the left and make a single and. The assembly
Uh,
just,
Single
No, no.
branch is the third case.
well, that's your other, I see. I mean, you have to crunk the window. Can I widen my window and get this? trying to see this part here. You said
Yeah,
unsigned
it shows enough.
long. Why am I doing unsigned long here? Can't I? Oh, you're shifting by 32. And you have more in there. Oh, you have this horrible thing in there. I see. I see. Okay. Yeah, this expression is difficult to read in these narrow columns. I'm breaking the line for no good reason.
Yeah, you can close ICC because I don't think we need to look at that anymore.
Oh, to get more space, let's see if I can figure out how to close
You
it.
can also turn off the mini maps on the editors.
I
Oh, I
yeah.
see. Where do I get the mini maps turned off?
You have to go to the settings. This is that.
Right now it's fine. We see the entire
Yeah.
line.
That's fine.
13 or
Yeah,
15.
okay, fine. In
Oh,
fact,
eh,
I
eh,
can, yeah, that's fine.
let me
So,
ask you.
Oh, you split it into two. 15 and 16 is the line.
I broke 15 and 16 in half. This is make A in the high 32 bits or in B. Now do a single test with C. And the code is shift DI by 32 in place because the register is that fat. I don't know what move SI is about. Or it into D, comp D to DX, that's the other value get passed, and jump around or fall through. This transformation.
Move ESI is the 0 extension from 32 bits to
You're
64
right.
bits.
Thank you. Yeah, I would use a different mnemonic myself, but yeah, right. And then the branch around is a reasonable thing with no heuristics. I do this one as well, with no profiling data. I assume that a exit branch, a test and exit is more common than a call out to some unknown thing that I have to inline and carry on. It could be big because people write cutoff tests. They just do that.
Yeah,
So,
I do that all the time.
right. So I'll give a no profile data random heuristic of 75, 25% or 90, 10% to this kind of a branch. And then the layout engine will sort it like this.
Clang does a different kind of layout. I would think that both GCC and Clang are good layouts, but you might like Clang a little bit more.
Shift, zero extend, that's thanks, Matt, or comp, jump. Yeah, he did it the other way around. This is less total volume of code.
Yeah, because the jump.
I'm sorry? Yeah, jump around.
There's no two returns. The GCC has two returns.
Right. I claim GCC's code is probably faster in practice, despite it being larger, because probably in practice, if the branch is highly predictable, then they both do roughly the same thing, except GCC's, no, they'll have the same iCache footprint because they're predictable, and the leftover bits will land in iCache or not, but it won't matter. If they're kind of random, but they're weighted one way or another, I think the usual story is that GCC's version is better because you usually don't do it. Test and don't. What was I doing here? Oh, I was thinking about saying, and then I'm so surprised that the and up here isn't done as a single and just do one test for the first single branch, please. That one's surprising to me. We'll call this single branch 1, and then we have 1, 2, 3 instead of the unlabeled. Ooh, and that caused the brains to explode. Okay, there it goes. Yeah. Anything else on this?
My question was actually like, so in the single, sorry, in the second function, we have like compare jump not equal, compare jump equal. So
Yeah.
if you want to rewrite this to use only one branch, what do you do? I mean, which instruction do you use?
You subtract A from B, you subtract C from D, you OR the bits together.
Ah, okay.
Oh yeah, that's a good solution.
How do I know? I'm pretty certain I've done that particular one. That's sort of the limit of what I would do in Hotspot. But that was the kind of thing that I did.
And I went with the bit shift instead.
With the what?
The bit shift in version 3.
Oh, bit shift. Yeah, I saw that. that was your
Isn't
manual
there,
bit show.
isn't there a slightly better XOR answer to that? Or are you
Well, you
thinking
have to
that?
make sure that the subtract doesn't leave identical bits that the XOR line up on each other.
I meant you XOR A and B, you XOR C and D. And then you
And then what?
see.
I mean, you might be able to OR them.
Right,
A minus B and A XOR B probably give you compatible answers.
right. But the minus has effect on flags, right?
Yeah, and these
x86.
days that's kind of like, you know, in Pentium
Yeah,
Pro
you're probably
days,
right.
but these days, like, eh.
And they're all half a cycle anyway, so it doesn't matter.
Right. Why is it?
Yeah.
Okay, Comcast is calling me. Just a second. Somebody else called. Hello.
Let's talk about how bad Comcast sucks.
There's no reason-
Yeah.
Well, yeah. There's like we're up in the mountains, right? The
Yeah.
wire's old. It comes down in the storms all the time. They're repairing up here all the time. They want to tell you that you're going to lose your Comcast because they're going to cut the line. And I know they're working on the lines on the road up here. At the same time, Frontier phone company from eons ago is trying to upgrade to fiber, and they don't want to deal with anything else. So a bunch of the lines are coming down. Yasser isn't here to hear that joke. What? All right, fine.
He was saying that earlier today.
So apparently I have not yet lost cable. And they're not telling me. I don't know. It was an empty call. It, said Comcast calling. No, no one home. Fine.
So when are you going to switch to Starlink, the thing that doesn't have the cable problem?
When Starlink gets the bandwidth and latency that Comcast has, their latency is through the roof compared to Comcast, and I think their bandwidth is also a little more flaky. Go to Burning Man. Somebody brings Starlink. It's pretty good, but it's Burning Man. You're fucking miles from anywhere. Up here, I got a wire to the house. It's mostly good. 2 or 3 times a year, it's down for storms. Otherwise, rock solid. Can't really complain about it. So I'm not buying Starlink yet. It's the only wire I don't have a replacement for at the house. Everything else I have. Solar and well and septic and gas and everything else, I'm off grid except for Comcast. Okay, are we done with this? Stop share. That was actually good roundabout. Adrian, you got your question?
Yes, thanks.
Yeah. So how to screw around. One of the fun things that I think every compiler writer ends up doing at some point is grabbing the GNU super optimizer or the modern equivalent, taking some stupid set of things like your little test case there, asking the GNU super optimizer to give a perfect answer for it, and then you put a pattern in your code to produce the perfect answer. There were several of them, some for Java, some for specific benchmarks, did some for C, whatever, C++, certain patterns were just like, this is stupid, there has to be a better way. And you ask, and sure enough, there's a better way. Pop count before you had an instruction for it. Things like that.
Yeah, I use pop counts quite often, and the trailing zero count
Yeah.
for whenever I do SIMD, I use trailing zero.
Right. There's a thing, there's a use for it. There was always a use for it. So people did them by hand. And then you ask the super optimizer, hey, and then some stupid instruction sequence showed up. And x86 was more special, having more stupid ones. But every processor had their favorite stupid patterns you could get and do something good. What else?
I kind of never understood why clear CLZ counts leading zeros. It doesn't have defined behavior if it's all zeros, and I thought that was a little strange.
Oh, it doesn't really. So x86 Intel can just not bother figuring out every generation the transistors do something different. Okay.
There's a difference instruction that they made to like replace it that actually has defined behavior when it's all zeros, but
Oh, they didn't just bother to define the behavior and walk away? It's interesting.
maybe it would break some programs, but I don't understand the compiler. I don't know.
Some programs are going to
C,
be,
but not assembly.
Yeah, the edge conditions on bit instructions on x86 have gotten me at least 100 times in the past 40 years.
Yeah.
So,
And name an instruction that sets the parity and something else bit, but not the carry bit. And there is one that I've been bitten on. You know, set 0 bit, set whatever bit, not the carry bit, and that's
and then the
specifically-
differences between instruction architectures where you shift, and the question is it a shift mod bit count or is it a shift absolute? That one's bitten me at least 5 times.
And x86 has changed their mind on shift counts. In older versions, they would just ran the counter down to 0, and then some version they chopped it, and then they did a barrel shift and whatever, and they got different answers from different generations if you exceeded the bit count.
And there was one CPU in the 90s, I think it might have been Spark actually, that the rotate was implemented in software and it would take longer the more times you told it to rotate.
Oh,
Microcode, software, microcode.
I'm not sure. Yeah, good point. Yeah.
Yes.
Something like that.
Yeah, and then you said CLZ, and what I immediately went to is Azul's cache line 0, not count line zeros. How do you round hex 18 up to hex 20? You add hex 8.
So you take 20, you subtract 1, you add it to the other value, and then you AND it with
I watched Tim Lehrer's new math video last night. You know, it's like the 50s or 60s or something, and it's just completely spot on. This is like 50-year-old video, and he nailed just your question just right there.
Wait, well, what's the solution again? Because I know how to check if it's a power of 2, but I didn't know how to
I
find.
don't know if I can find this in my recent videos history, but he just, there's an answer here.
So you take the leftmost bit. I think you subtract 1 and take the left. Yeah, it's shoot, I haven't done it in a while. But basically, you get the high bit, you minus 1, and that gives you all the 1 bits, and then you add that to the original value, and then you
Not today.
take the high bit of that, and that's your answer. So there's no conditionals is the point. You can do it with conditionals and less code, 1 less instruction or 2 less instructions, but it's slower in theory.
My slow way that I just implemented the other day was to do a leading 0 count, then bit shift 1, like 63 subtracts bit counts, or actually it was 64 subtract the bit count or leading 0 count, then shift 1 up by the amount, and that was my solution, but I didn't really like it.
So the new math videos in the chat, I don't know if it deserves to go into it's very unrelated to compilers, and not necessarily worth watching just exactly right now, but it'll explain how to do, you know, base 8 math in, you know, 1950s piano, new math style, which I can't believe you came up with that. And I watched this video just the other day. Fine. And what are you asking, Aaron, about how many definitions of percent? What is your question? Oh, Hacker's Delight. How many definitions of mod? Div? Rem? They're like 5 or something. And everyone agrees that mod has many versions. Yes, like everyone agrees that like 3 are shit and 2 are highly competitively equivalent to many people who will argue with sharp knives at each other about which one is the proper version. The one that I'm fond of is the one that says that whatever dividend times quotient plus remainder is result or whatever. There's one that you just do the obvious inverse math to get the correct answer. And then there's people that hate on you because negative numbers give negative remainders or something stupid. It's fine. All right. We have how many definitions of mod? How do you round up? Aaron doesn't use pop count. No, I've used pop count, so has Levo. Yeah, it's convenient for things.
I don't remember getting using the remainder of a negative number, but I just don't remember it. I'm sure I'd done it.
You know, right, exactly. I don't either. I want to say I have a hack in C2 to recognize when people take mod of a hash as part of a hash table lookup. Mod hash table size. And there's some hack I do to know, like, you don't get a range check fail ever as long as you're not negative or something, and I can cheatiness, but that's very specific to Java hash tables. Round A up to power of 2 inclusive, get highest bit decrement at, yeah, right. This sounds like straight out of Hacker's Delight there, Cameron. And in fact, I think I have done that if I needed the next larger power of 2, and I generally don't bother very much because it's just not performant enough. I do the obvious thing, walk away.
The other pattern I've seen is you put the Hacker's Delight into your code, and then the compiler replaces it with one instruction that does that you didn't know about.
Yeah, I've done that. In fact, I've put the pattern match that straight out of Hacker's Delight. You can write, you can write a carry bit test, an add with carry, in such a way that the test for the carry bit that you would add when you're doing multi-precision arithmetic and like big decimal, big integer by hand, that the compiler can easily spot that you have a carry available and just use an add with carry for the next instruction. And I put that pattern in, and I told the big integer folks about it, and they knew about it already. So they wrote their code that way. And lo and behold, big integer compiles with add with carry ops. Fine. Well, it was hardware software co-design. It was library compiler writer co-design. But yeah, Hacker's Delight.
Yeah, when I first heard of the JS ASM, it's like, we're going to write the JavaScript for the assembly instruction and then let V8 just replace it with the real one.
Oh, yeah.
And I was like, this seems like an overly complicated way to spell a simple instruction. And it was only later that I realized, oh, we already do that, where we write the C code for a complicated instruction.
Yeah.
And GCC just replaces it with the one instruction.
You're
it's like,
hoping
oh, we've been playing this trick for decades.
The intrinsics, yeah.
Yeah. You wrote this pattern knowing that it'll get intrinsified. No, the JavaScript guys, that's a great answer.
Pattern or library function, yeah.
All my other infrastructure in place to go compile and debug and edit and run my JavaScript. And right here, I need some fucking performance. So I'm going to write assembly language in JavaScript, and it'll be valid assembly and valid JavaScript at the same time. A little ugly on the assembly side, but we all know what it's trying to do, so it works.
Particularly if you have a library and you just give those things names that sound like the x86 instruction you're trying to do.
Right. And lo and behold,
it looks like reading x86.
Library writers not pattern matching the function name so that a hacker could come along and pattern match the same function name, but with different code.
I mean, it better be matching the actual code.
I caught Intel playing that game and smacked them around 30 years ago. They were cheating at a benchmark using the function name. Fine.
By the way, the function that we discussed previously with the 2 branches. So Cliff mentioned you can use 2 subs and then OR them and then like test and jump, or like you can jump if they're equal. But the thing is, like, so I ran this a bit through this like machine code analyzer of LLVM.
Holy crap!
No. I wanted to say that so one problem with this, like going with the single branch version, is that you actually increase your dependency chain a lot, and also sub modifies the register, whereas a compare does not. So like there are lots of optimizations that the CPU can do in this case. So it actually looks like the 2 branches, especially because a lot of times the compiler writers assume that branches are in general often predictable, that like the throughput will actually be really, really good if you use 2 branches instead of 1. So like,
if they're predictable. If you were to write a test harness that threw random numbers that were weighted such that the branches were highly unpredictable, you might find that the two subs and a XOR and a branch would be better.
Yeah, for sure.
You don't need to compare.
It's also less predictable from the compiler's point of view with the multiple conditionals, because each generation of each manufacturer's chips has a different depth that they optimize their branch prediction to. So it's like 2, you're fine, 3, you're not. So you build a compiler that only does 2, right? And then the next generation comes out and supports 4, and you're like, oh, you know, or vice versa.
Right.
Yeah, so
Does this
Intel
change
it
with
hasn't
risk
released them
versus
yet,
this,
but
or-
the new Intel chips actually dropped the hyper-threading, for example. So basically all the oh, you didn't, yeah, it's not public yet. Sorry. Don't record this.
I didn't hear this.
But so all the code optimizations that we not I did for knowing that hyper-threading was just using spare units on
Yeah.
an existing core, those are bogus now. So all those assumptions are gone.
Interesting. Like it made sense to me because you would get a memory stall. And so fine. Okay.
Does targeting a RISC architecture solve some of these problems, or is it just the CPU is really complicated? So the
There's no
architecture-
such thing as a
is-
RISC architecture, not for 25, 30 years now.
Oh,
If you think about GPUs, they use hyper-threading to a very large extent.
yeah. I'd say TXUs looked Azul CPUs whole look like a RISC.
Right. And there are
classic.
exceptions, but I'm saying like ARM is not RISC.
Oh, okay.
Like after I learned the 4000th ARM instruction, I realized that reduced was just in comparison to x86.
Ah, yes. Yes.
Same
Still
can be said
half
for
as
RISC
many as
V.
x86.
It's not very well defined what RISC really means. Arguably, it was never well defined what RISC means.
You know,
It's a
my
marketing
version,
term, for instance.
the
It
version of
means
RISC I
not
grew
made
up
by
with
Intel.
was it had 1 memory op per clock cycle, as opposed to a VAX, which had an arbitrary number per register or whatever, per instruction. So it was trying to say, you know, we're bottlenecked on memory in the load store unit, so we'll just make you write an instruction 1 for every load
Yeah.
store unit.
And so that's why Sun in their Niagara architecture, basically they sliced, instead of adding more units so they could grab ripe instructions for scheduling off a second thread for those units, they just subdivided the CPU into eight threads. So basically each 8 cycles, each thread would begin executing 1 instruction.
Oh,
So basically they slowed down the spark by 8x.
yes.
And but that's because the gap between the memory performance and the internal CPU performance had grown pretty significantly. So as long as you were doing memory, as long as you were waiting on memory all the time, you didn't notice how slow the CPU was.
Yeah, I kind of wonder if how many cores per stick of memory is like ideal, because I don't think like 20 cores would be too helpful, but I don't know how many RAM sticks people typically use nowadays. I still
Right.
use 2.
I still
Yeah,
have
it's not about the number of sticks. It's about the number of channels and the width of the channels. So
Yeah.
how do I get rid of the side mini maps? Just like a
Editor. Go to editor
editor. Oh, geez.
and show editor minimap.
Wow.
Yeah.
Okay. That was not where I was going to head. It's like arbitrarily randomly search all possible choices. So what's this one trying to do here, Levo?
I haven't looked at it too much, but I did notice that GCC and Clang put a lot of pushes, and for some reason, ICC stopped putting pushes.
Oh, this is like reverse. Okay. You're just like counting pushes here. x86 tries hard to make pushes cheap. Okay, so here's an initial test. Why are you doing the, where's your branch, dude? Here's the loop.
So Matt, aren't pushes now free pretty much on x86 and ARM?
Oh, and ARM has pushes?
ARM did the
Fine.
well, they don't they both now basically do this as register renaming for all practical purposes?
Right. You have to hoist the Intel been doing it as register naming for a while. You have to hoist the stack. You have to alias against stack choices for people other things, and then yes. But Intel made sense because pushes and pops were the way you got more registers on Intel for 20 years. So of course they optimized it.
Yeah.
In A and B, sub, jump out, Y. Okay, so that's probably in test R13B. Skip around, do a weird add, 3 address add. Okay, comp jump. What the hell? I'm looking at the code for GCC and like RBX, and what is RBP here? It's holding on to something.
Well, did you look how weird my fourth test case was? I tried to make it so it wouldn't cache the
Well, it's
branch.
up on the share, right?
Yeah. But
And
did you look at the N and B, how I subtracted every iteration?
Yeah, right. I'm looking at your subtract. So I'm staring at the code that GCC emits and trying to figure out why they're adding RBX, RBP, moving it into EAX, comparing and looping. Why does this sum, this is your while in, right? This is the test for in being 0. They have an initial test, they've partially rolled the loop, that's all reasonable. Then they're testing, I don't understand what that code's doing. Fine. Subtract 1, okay, you subtract 1 from B. You subtract 1 from A as well. Oh, I see what they're doing. So they're rebasing in and B to be the same base. Probably trying to fold in the test for A because there's only 2 tests in here, but you should have a test for in to exit the loop and a test for A and B to skip. Oh, there are 3 tests there. No. They've rebased, so they don't have to subtract 1. This is like someone's an induction variable elimination. Said there's one induction variable for in and B, and that's what's going on. That's the compare. Okay, I get it. Let's see me go look at the number 2 here. It's just like ugly in a different way. But again, here's an increment instead of sub bx. I'll add 1. Okay, I'm inverted somewhere. Compared to the exit case, then I test A, test B, and jump around and loop. I actually claim this is more readable, although they've inverted the test, which is fine. What's this other guy doing here?
So instead of pushes, they do moves. I didn't catch that at first, but
Oh yeah,
it was
butt ton
both
of stack
pushes.
moves. Yeah, the opening line is sub RSP, 24. Give me 3 words on the stack. Let me spill 3 words, get 12, 13, 14 available. Then I decrement because the code has 2 decrements. Test 1, test the other, skip, test the exit jump. That's certainly that loop looks a lot more true to the C code. Why there are all kind of weird things going on. You know, the guy on the right has 2 decrements. The left 2 guys have one. One does increments and one does decrements. They've clearly done induction variable replacement. Well, it makes the code harder to read, but performance-wise, I can't imagine they're actually hardly any different at all.
I just find it a little funny that they still all don't make that if statements a single jump.
Yeah, they're hard. Yes, they're like trying hard not to. Like, how can you not do this? Why would you not do this? Fine. All right.
Yeah, that's all.
And then Matt's saying, oh, something in chat about Stack Overflow as latency is lying. All right, fine. Let me go look at. I'll see what Stack Overflow. Where do we do x86 assembly day? What the hell? Oh, there you go. All right, accept all cookies. Hit my share button. People can watch and look. That's a Stack Overflow link. It'll show up in the. Oh, somebody doing anything with the docs and the discussion? Because I'm not writing things down here. No. Yes. Levo, micro optimization profiling. Yeah, throw the links in from chat in there. Yes, I heard push was only 1 clock for a long time. Now this guy says it's between 2 and 11. Okay. Yeah, I don't know. Oh, I see. So they're claiming it's a store. It obviously is.
Right, but it doesn't block the next instruction. Doesn't matter how long it takes to retire the cache line. It matters how fast you can start the next instruction.
Yeah, yeah,
And as far as I know, push is still pretty much 0.
yeah. No, it's 1. Pretty much zero.
Right, it may be 1, but it can start, the CPU may,
Yeah.
Matt, you're gonna have to speak up here because I haven't tested any of this in 20 years, but 15 years anyway. But it'll start the next instruction on the same cycle, right?
I'm guessing from what I'm looking at, yeah.
I think some of them are cheaper because of the stack engine. So that's the part of the microarchitecture that makes it faster, but it still depends. And the answer goes into what it depends on. But also storing on the stack may be fused, as they point out.
All right. We are well off into the x86 weeds here.
I have something compiler related.
Uh-oh.
Another Godbolt link though, but it answers, like it brings a closure to our discussion before. So basically, it's the same code as Levo's second function at the start, but with the built-in unpredictable intrinsic. And
Oh,
Clang,
built-in one.
yeah, basically Clang, it's all about being predictable, right? So the Clang by default assumes that branches are predictable, so that's why it emits 2 branches, and 2 branches are better in those cases. But if you have more knowledge than the compiler about this branch and you know it's unpredictable, then yeah, it will generate the XOR or jump for
There
you.
it is.
So
But my
that should
Zor
answer
Zor, I
Leo's
guess I
question.
said sub, but yeah, Zor
Yeah, you said
Zor.
sub, right? It's
Yeah,
the same
yeah.
thing.
Oh, I think Cameron was trying to say Zor Zor. And it's actually probably faster because it doesn't dork the flag so much. Yeah, could be. Sure enough. Okay. So there's some sanity in the world somewhere. Not on x86
You
ops.
just have to be slightly more verbose, but I typically use likely and unlikely in my
No,
coding.
those two are very different things. Matt had a nice presentation on these keywords, I think. But unpredictability and likely versus unlikely are 2 different things. Because a
Yes.
likely branch and an unlikely branch both have are
Yeah.
predictable, right?
Yeah.
So,
And it used to be the other reason we use Zors is because they often packed tighter than some of the other instructions.
Oh, yeah, it was one of the early ops. It's all tiny. Yeah.
Also,
So yeah, for the
branches-
16, sorry, Matt, go ahead.
It's also branch, it's just a quick comment. A branch that is taken, not taken, taken, not taken, alternating is perfectly predictable for any modern CPU. But notice that it wouldn't be either likely or unlikely.
Right.
But
I think
it is perfectly predictable.
I think Intel was good for a couple of repeating patterns. Not hugely complicated repeating patterns, but there are a couple of them he'll take. And I think he's more than just even odd. I think he can do 1 and 3 or 1 and 4 or something. He can count small numbers of taken, not takens. All right. Once again, I'll kill x86 branching Godbolt for no good reason.
A question, I guess. I didn't really have one when I joined this morning, but I thought of one. If you want to talk about something different.
Yes, whatever.
It was, yeah, the place I was just contracting at, I was a little surprised. They use Scala and they use list as their sequence, like their default immutable sequence. And the list in Scala is, it's a class with 2 subclasses. It's either the empty list, that's one thing, they call that nil, or a const cell, which just has 2 things in it, which is the element, which is a pointer, and then the point, another pointer to the rest of the list, which could be empty or not, another const cell.
Right.
The thing I thought about, I mean, it's like 1 element at a time, and if they call it linear, so like for small data structures, it's when you analyze algorithmic complexity, it's linear time because you got to go hop, 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 hop. If it's 1,000, you got to do 1,000 hops. If the length is 1,000, if you're gonna or something. If it's 1 or 2 or 3 or 4, it's only 1, 2, 3, 4 hops, which is like maybe okay, except if they're not in the cache, is what it just seems like they're not co-located at all by guarantee at all.
So I did in fact, I taught a class for a while that on linked list versus array list. And basically at all scales and all dimensions, array list is faster than linked list by factors varying between 2 to 5, depending on your scale and whether you fit in caches or not. It's always faster, never slower. Always faster by a substantial amount.
And how is array list structured? This is the Java array list, is
Yeah, but in other languages you call it a vector. It's a pointer, it's a struct that contains an array and then a length count. And it contains in a max length of the array, a contained amount in the array, and the array.
just one array that has the entire sequence,
Yes,
no matter how long it is.
that's correct. Now, once you get to the billions, you could, do chains of things under the hood, and it wouldn't change the asymptotics here at all.
Okay.
Once you're well exceeded caches, it doesn't matter whether you microarray you under the hood or not.
Okay.
But
And
yeah,
what about
any length.
these? Like, let's say it's immutable. In an immutable array list, when I just do like add one to it, add something to the beginning or the end or whatever, I have to copy the whole thing.
No.
Me, that sounds like, well,
Okay, so immutable adds a whole nother game. So yes, you do something different. There are delta encoding structures that are suitable for immutable. Closure, for instance, is full of such things because that's all their default model.
yeah. So it's got like a vector that kind of was, it's Phil Bagwell designed it, and it went to Clojure first. And it's got 32 elements, so it's an array of 32.
Yeah.
And, for most things, there's, in enterprise software, it's going to fit, right? And so you just have an array. But if it's like 33, then that first array at the base of this tree is pointers.
Yeah.
And so, you've got 2 pointers that are used, I think, is how that works. And so one of them.
You asking where the trade-off is?
Well, I thought it just seemed to me like that's a better default. I mean, I think I was surprised that they used list because of, I know it's an elegant data
Yeah, it's
structure.
elegant. That's why I use it, but it's not.
But it just doesn't seem,
That's my take. Yes, doesn't
Well-
seem reasonable in any large scale system. And
Yes,
and
the things I was
if
thinking about is the copying. It seems to me like a copying from one array that's less than 32 to another one is going to be faster if it's in the cache than like following one, and
this all goes to your usage and profiling data.
Yeah.
If I have a million arrays of 1 to 2 elements, I want a one kind of a structure. If I have a one array of a few million elements, I want a different structure.
Yep.
If it's going to be immutable, I want a different structure. If it's going to be, the one array of mutable and I have multiple users, there's something going on here, then you need something else.
Right. Some things, but so if it's immutable and it's used by one person, like one thread, and it's like enterprise length, a handful
So
of
you're defining enterprise length as
Like
some
4S.
bell curve peaking at 20 or 30.
Yeah.
Okay. Or I'd actually probably say it's more like it's
Good.
usually an
I would just call
inverse
that big
function.
data.
what would be a good data structure, the best data structure to be your default, like for programmers?
Yeah, I claim that the default for me will be array list.
Okay.
So if you're thinking immutable,
Yeah, if I'm thinking immutable.
and maybe I can append for free if I just carry a different lengths by the different people who are appending. Okay, whatever.
Okay.
But a lot of folks will have 0 to 1 or 2. And then some folks will have 10, and one stupid guy's got 1 billion or 1 million. Right. And I claim it's not a bell curve. You're usually looking at this reciprocal curve.
Yeah, we call it long tail.
Yeah. The product of the length and the count of things is roughly the same. You have 1 million one-entry items and 1 million entry items.
Okay.
Roughly.
1 over X.
Yeah, 1 over X, reciprocal, right. And I claim array list. That
Okay.
is your good, best first cut default. If you wanted to have another cut, I would have a version of array list that started out with, what do you call it, the inline data structures. It was like null, it meant you had nothing. And the thing that was not an array list, if you had 1, and the array list, if you had more than 1, so 2 or more, and then the array list internally may be able to capture those in fields first before he flips over to an array.
Okay.
And then an array from 4 to infinity.
It's called a small buffer optimization in C++.
Yeah.
where you basically have data structure that can either be storing data in line, or it could be storing metadata and then the pointer to data or something like that.
So in C or C++, I would do that. And in Java, because you can't do that terribly conveniently, I'd start out with either an array list or an array list that didn't have the array for 0 or had an element for 1, but at 2 or more, it was an array.
Java's been adding those optimizations behind the scenes anyway.
Yeah.
I told you the story about the hash tables, how we had the some horrible percentage of memory used was empty
The
hash
default was
tables.
101 elements in a hash table at one point.
And then strings, we did the ANSI, sorry, the ASCII, so multiple encodings behind the scenes. But yeah, there's a bunch of, they're just doing one at a time,
Yeah,
but I mean, it makes a big difference. But the other thing we've seen is that 30% on a typical application, and this is true for C as well, typical application spends 30+% of the time copying arrays.
I've heard that from Google.
Whoa,
So,
what?
Yeah, Google actually did a study too.
Yeah.
seems like a
Snorkel did a study and Google did a study. Yeah, over 30% of wall clock time is spent copying arrays.
It sounds like that sounds high enough that people should just be using Java. That doesn't need to be copied.
No,
Like
no.
copy the arrays.
The
Oh, no,
Java guys
Java
are copying.
spends, all the
Yeah.
time.
Yeah. See,
Java
guys,
too.
Because strings are arrays,
Yeah.
right?
There's some lifetime management where the best easy answer is make a defensive copy and walk away.
Oh, wow.
Expensive copies, yeah.
I mean, I'm assuming that's where most of them come from. And I go look at, I've done this for other people's like performance hacks. The sort of the number one easy thing that comes around is tell them to stop allocating. And then why are they allocating? Well, they don't know better. So they just got another one. And then there's some version of hash consing, intensification, thinking about where the data comes and where it goes. And you can cut out 90% of their copies. And lo and behold, their app speeds up hugely and their GC pauses drop them tremendously. And they're all super happy. And I'm like, gee, give me my money. Okay,
Yeah,
fine.
but the amount of time, if you read the C++ mailing lists for the language design and stuff, the amount of time that gets spent on optimizing mem, CPY, etc., is it's dramatic because it has the biggest impact possible on, like, there's nothing else that comes close to 30%. Although it may be changing with AI, I don't know.
Whenever you ported hotspot, like the first thing was to get the compiler and the JIT running. And as soon as the JIT was running sufficiently, it didn't crash everywhere, you went after the default mem copy you got for free. And C2 and the runtime that came with hotspot has this huge infrastructure for optimized array copies. And you turned it on and you had to write the assembly hacks for every possible alias, offset, whatever, alignment, length. There's a bunch of variations, and there's this very carefully tested series of branches. If it's size 2 and I know it at compile time, and if it's 4 and it's aligned this and this, and you branch this very narrow branching or very carefully tweaked branching sequence, ending in a blob that did, the correct copy up to whatever point that you could go to a big copy. If it was big, eventually you didn't care, but all the short copies had to have very carefully tested branches.
I wrote my own memory copy because when I was compiling without the C runtime, the compiler demanded I implement it.
Yeah.
I wrote one and I measured it. It was like basically the same as the
You
one
say you
that
measured
shipped
it?
from
What
GCC.
did you measure? Did you measure copying an array of million elements?
This was like 3 years ago, so I don't remember.
So-
But I would imagine that I measured copying like a loop of small bytes, like 5 bytes or 3 bytes, something
Okay.
that's like awkward. And
Right.
then I don't know how many iterations, probably 1 million, but
Just
then I also
I'm surprised Matt's not speaking up because they're like GCC alone has, I want to say 20 different mem copies. Like for
Hotspot does.
inlining,
Yeah.
it's like 20 different,
Yeah.
like it looks at your code and says, I think I
Right.
should use this mem copy here because I don't know if these are aligned or like, so you have alignment, you have size.
Yeah. Yeah, right. And if I'm going to start short, but I don't know, but if I know, I'm going to skip the short guy, and then I'm going to eventually hit the prefetching, streaming, big ass copy. Way far down the line in the Azul version, there's one that said, these are too big of an array. They're not ever going to move. So I'm going to flip to TLB page mapping. And we could cheat you that way.
If you guys want, I can show my mem copy, but I think we criticize enough code code samples today.
No, it's entertaining because there's a lesson for a compiler writer here. You said I tested the short million entry guys. That's a great test. There's also the test the one guy who's copying a gigabyte. Okay, there's this reciprocal curve where I need to test 1,000 guys who are running 1,000 bytes of a copy. Then there's all the misaligned versions of things. Then there's the overlapping misaligned because somebody's actually trying to do a fill. Well, they didn't call it a fill, but I can't tell it's a fill till at runtime I test, oh shit, overlaps tightly, it's a
And
fill.
then the runtime libraries as well, look at which CPU you're using, because depending on which CPU you're using, you may want to avoid the AVX based copies. So AVX 512 had some of the fastest copy times, unless you were like, if you already were doing some, like there were all
There was
these.
something going on. Yes, right. Yes. Shit. Was
There
all,
is also the thing with the iCache trade-off. So glibc has this huge memcopy implementation that has a lot of branches to see, am I copying large data? Am I copying small data? Is it many elements? Is it not that many elements? And the problem is that those branches are all code, so they take up space in the iCache. And even though this looks great on micro benchmarks, it may slow the entire application down when you actually put this in real code.
Oh, really? Because there's so much.
Yep, it pushes out the hot code that you want in your application to be in the iCache out, because now you have memcopy in the iCache, and you only have memcopy in the iCache.
I was always very leery of that when I was doing these memcopy implementations for Hotspot and other compilers. You watch that carefully. Is one of your with known overheads. But you still want it to say shit like it's 2-byte aligned on 2-byte boundaries going to a non-overlapping blah, 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 blah. And and you get a bunch of versions.
I want to grab a drink, but I threw up my code in the chat and I haven't looked at it for years, so I don't know if it's any good.
I don't have anything in your chat yet. I've got
in the Google Docs, I mean. Be right back though.
Oh, that's fine. I'll find it in Google Docs and we'll throw it up while you're getting your drink.
I guess it's 5 o'clock somewhere.
I'm about to say I was gonna make the snarky comment. How much alcohol is in the drink? Okay, big font. Oh yeah, classic. If size is tiny. And then copy no alignment check. Unless you can guarantee fixed alignment here. Or you don't care because it's x86 and he won't die on misalignment. Then he says, go do alignment, go peel. But that's a full 8 bytes because he says he's already 8 bytes. So less than 8, he does less than 4, 2, 1, copy bits. Yeah, that's pretty common. So down here is the...
Okay, I'm back.
Yeah, we're debating how much alcohol was in your beverage.
Oh, it's just coffee.
It's 5 o'clock somewhere. Well, but you know, Bailey's coffee's pretty good. Never mind. All right, enough of that. Yeah, so here's your size less than 8 copy. 421, pretty sensible no matter what. Here is a copy with no alignment check. Actually, this one's no alignment check down here on the 4 byte.
Yeah, it's no alignment check, so you should reverse them to do 1, 2, 4. But in that way, well.
Yeah, I don't know. I don't know if that's CPU specific or not. Like no alignment checks mean shit like, hey, I crossed a cache line boundary. I'm not atomic. Hey, I crossed a TLB boundary. It may test and reset and retry, and it had giant holes for non-atomicity and shit like that. Okay.
Does that matter on modern processors? Because I thought online was just as fast as aligned.
Oh no. Oh no.
No?
Oh, no. It varies very specifically by different kinds of folks. But as soon as you cross, most of them, if you cross a cache line, you're double pumping memory somewhere. But also, there's no guarantee of atomicity, which I don't know that it matters here. The usual story is if your data is not aligned, it does not need to be atomic, and shearing is okay. Never mind, early x86s with 64-bit math had a shearing thing. If you're not in one of those cases, then shearing's probably okay, but you have to ask the application, can I shear?
Right. So two things. Right now, I don't support threads. And the other one is this is the case of less than 32. So I don't think I think
Yeah.
the branch mispredict would be worse than the alignment problem.
Yeah, and then because it's x86, he says alignment's okay. I don't know if ARM will allow you that. I suspect a RISC-V would blow up and say, this copy is misaligned. I'm just going to explode on you. You're just wrong on a RISC-V. It's my guess.
Yeah, yeah. I remember having that problem when I did ARM 5 or something.
It
I don't
definitely would
remember,
be
but-
broken on a Spark, on a Itanium, on an Azul TXU. On some early versions of ARM, I'm pretty certain it would be broken, so on and so forth.
Spark would, yeah, Spark would actually fault into user, well,
They
fault into
had
user,
a,
would fault into code that would then do the unaligned move.
right, that was added later to help people report their VAX code. But in the land of Java hotspot, we just said, don't bother. If you hit this, you're dead. And
Right, well, you'd lose several hundred cycles for
Yes,
one,
so bad.
for a 3-byte copy or something, you
Yes,
know, like,
it was
what?
so bad, we just said, don't do it. It's our bug. We'll just fix it. So, all right, then I see you do alignment. That's all reasonable. Now you go to array syntax, fine, and you copy another word, and then you subtract 8 and copy another. And because you're 32 limited, you're just counting them down to get your 32. So that's actually short. So this is sort of reasonable here. There's no fanciness for alignment. You don't do a MIM, an overlapping test. I don't see an overlap test here, which is actually a MIM move.
Well, I just start with the smaller, like less than 32. The second if case is less than 8.
Right, but suppose that I'm copying a megabyte from source to dest +1 or dest to source +1.
That would be on the line that starts with auto block after the else statement.
Right, so I come through here. Oh, I see. So if I do, well, let me do this. We'll just do this test right here. I'm copying 31 bytes, and they're off by 1 byte on the misaligned. So I would do this, which in x86 is probably okay. No, he would stomp you. I could arrange that you stomp the wrong way on a MIM move. If I misalign you one way or the other, you'll load from here and right to here. You'll load from here and right to here, but this will stomp the other half of the bits. I want to copy everything one byte to the right. So this byte in the middle between my fingers here wants to go 1 byte to the right. So I read 8 bytes, and I stomp it over here, and I just crushed all my bytes. So when I grab the next one, I'm off. I don't get it. One of those two shifts, maybe I got it backwards. It will be wrong for an overlapping in the range here where you grab 8 bytes on the highlighted line here.
You can
And
also
right.
you can also compare with the LLVM libc version. I posted this in the chat.
Yeah, I'll drag it up in a second here. I'm curious. I'm sure it's ugly. So I'm not trying to nitpick your code. The original,
No, nitpick away.
the original thought was your testing sounded naive. So I was actually hammering your testing strategy. The bigger block moves here are probably, other than overlap, are probably reasonable. You have to catch your in case.
Oh, right. Okay, so this is a mem copy, not mem move. That's why I didn't do those cases. I
Okay.
don't remember if I did a mem move, but I
No.
remember seeing
What's
move.
MIM copies? Is it undefined behavior if they overlap, or is it well-defined?
Yes.
It is undefined behavior.
Yes.
I don't
So I
really
remember
expect
seeing mem move being generated from GCC from Clang, but not GCC. And I'm like, I don't do any overlapping copies in my compiler, so I just like butchered this code. I just didn't.
And then here you've taken the block of size greater than 32, and you got the odd bits, and you move.
I completely forgot, but I always meant to ask that if the alignment, okay, so if the destination or the source is aligned to 32 bytes, that's at least one of them. That's good, but you still have to do an unalignment on one of them.
Right.
But I was like wondering if I have to choose between destination being aligned or source being aligned, Actually, wait, I think my question is wrong, but
It-
I was just wondering if it's better to have writes aligned or reads, or if it doesn't
in
matter.
the chips of yore, it was better to have the writes aligned.
Yeah, I
On
assume
a
so.
modern chip, I don't actually know. If you read a line, he doesn't have to double pump the read side, and the write side can sync fairly fast with a long, deep pipeline. So that if he takes double work on the right side, it goes into this giant ass store buffer, and he folds them and syncs them, and maybe you don't care. So I don't know if it makes a difference, or if it does, it might be faster to be read instead of write aligned. One of the two is misaligned, is what you're basically saying. And that might be architecture specific as well. So I claim you should check for overlap here. You're saying it's no, you don't have to. You're saying if they overlap, it's undefined behavior.
Yes, for mem copy.
Okay,
For mem move, yeah, I would definitely have to.
let me grab so maybe it's fine. I don't know. So this is LVM memcopy.h.
The entry point is at the end almost. It's the inline memcopy x86 function. Yeah, not the last one, but the one just above. Yep, that's the one.
Ah, here.
That's
Yeah,
quite
okay.
large.
And he says, if I have x86 AVX, chunk it in 64, or chunk it in 32 for AVX, or chunk it in 16 for SSE, or chunk it in 8 from using registers, I guess. Count as 0, get out. Count as 1, built-in mem copy 1. Wow.
And this is compile time constant. So those are basically all stamped out at compile time for this specific size and this specific vector.
Right. Yeah, I get it.
And they also switch between AVX, ASSE, and do prefetching instructions depending on whether you have prefetching or not.
Oh, really? They're going to do
Yep.
x86 prefetching?
It's above. You have the versions with prefetching above that it jumps to. And
There is
notice that
there is a
dispatch is-
prefetch on an x86.
Oh yeah, and most of this dispatch is at compile time. It just stamps out a lot of code.
Oh, this is all inlined.
Well, it's
Yeah.
easy
And
to be inlined. Yeah.
If const expiry is all compile time dispatch at this point.
Right.
The
It's
thing I don't like about this code is there's a lot of if statements at the top, like count
Yeah.
1, count 2. I just went down from 8 to, and then just ended.
No, but those if statements are free.
Yeah, they're compile time if statements.
Okay, because when I wrote my mem copy, it was because Clang or GCC didn't know what the size was and
Yeah.
couldn't do it.
I'm asking, yeah, how are they compile time if I'm coming from some random point? You're saying it's inlined at each call site, but count.
Only the regular ifs are runtime, but the if const expiry is compile time.
Okay,
But
yeah, so
These
my-
are compile time, yes.
Yes. And
Okay, no,
the
but
if-
these are not. This
and
is,
these are runtime.
yep.
yeah, so I don't like that.
I hear you. So this for me in the land of, compilers of inlining, if I knew the count, I in fact would increase the odds of inlining. If I saw constant arguments, C2, if I see constant arguments, I raise my thresholds. And if this constant here turns into some interesting number, like 17 or whatever, then these all fold up. All them counts all just disappear. If it's not a constant, and then you're right. And then it gets big. And now you have iCache. And so you decide to inline for iCache reasons or not. This const expiry I see full. So these if tests are in fact free. The vector size is free. This is not. Oh, it has test versus count. Yeah, okay. Yeah, and that's also going to disappear. Somebody else is highlighting this greater than 64. Yeah, and then there's a big one. And there's another big one down here with prefetching turned
You
on.
can scroll up for the definitions of these. These are all-
I think that's fine. If the theory is they're big, then I don't care to inline them because that's not where the overhead goes. Like the
Yeah.
win on inlining is all the crappy tests like if count 0, 1, 2, 3. So as soon as they're big, I don't need to inline it. It says inline mem copy, but you already got here because you're big, and then I claim, Now he says it's not that big. If it's 128 or less, maybe I would inline. Okay. Somewhere
there's-
around 256 or whatever, I'm like, going inline. It's a clock cycle inline and then, you know, or not, or whatever, because you're not getting any more folding. You still have to do all the work.
So on line 184, I was kind of confused about why, like, how do they figure that one out? Like, what
Const
is
expert?
use? 184, it says use software prefetching.
It's a
I
build
thought that
time.
would be everything.
Right.
Like
So
I don't really
It's
understand
a
that one.
build time configuration. You can build different versions of the library depending on your target.
Okay, so K underscore is like a compile flag.
Yeah,
Well,
so you can think of this as a define.
The const expr is a compile flag. I mean, not a compile flag. Const expr is this will be turned into a pound define. Yes, a pound define. The next expression will fold away to a compile time constant.
Well, okay, so I know that AVX is basically on all CPUs, but I also thought if you have AVX, you would have like software or hardware prefetching. So what's software prefetching? Like I kind
I
of
assume there's an instruction on x86 that you fed something to the prefetcher. What do what do you expect out of software prefetching? Certainly land of, other chips I've done where they didn't have a hardware prefetcher, you wanted the software prefetcher.
I don't know how many cycles ahead of time you have to like emit that or
Well, I assume
execute
that's
that.
buried in this here code down and one down below it. The AVX greater equals 64 software prefetching has some magic constants internally to it that says prefetch 8 cache lines ahead or whatever the number is.
Okay, yeah. So I didn't see the entire code. I just noticed that define before you showed the function. So yeah, I should have just waited and read everything.
Is that guy going to be in here? Greater software oh, here. Yeah, it's just the one right above. I think this is the guy. He says use software prefetch. So somewhere in here, he
Yeah,
says,
so it says 1, 2, and 3 cache lines ahead. So
oh, down in here, 1, 2, 3. There you go. 3, huh? Yeah,
that
okay.
sounds a little early because if it has to go to RAM, that might be like
Well, it's like,
I don't think that's enough if it has
how
to go
many
to
can the
RAM.
hardware sustain? Suppose that you get here because your count is many megabytes to gigabytes. You're just not going to fit any cache. You're blowing out your L2, maybe blowing out your L3.
You know what?
Sustaining. What's
The better question would be, what CPU is this used on? Because for all I know, this could only be on embedded.
Somebody with an AVX and software prefetching turned on.
Yeah.
And software prefetching turned on just means that it's available. And now you're going to tell the hardware something that the hardware probably can get on a mainline desktop x86 hardware probably will do this.
Yeah.
If you
On
open
a
that,
small embedded, maybe
if
not.
you open that link I just posted, it's a build time configuration. And there are 2 different prefetching instructions. There is prefetch instruction available in SSE 4.2, and there is prefetch instruction available in AVX. So depending on what you're building on, you are going to enable one version or the other. But this is just a build time target specific config.
Yeah.
I would imagine hardware would just do it.
Not,
Well, but you have different prefetch instructions in SSE 4.2 and different prefetch in AVX.
Yeah, I claim this is going to vary all over the map. Certainly in the land of C2 porting, we asked what chip you were at runtime, and we changed how much prefetching for what chips you were on.
Because nowadays, I would assume you were gonna have at least AVX, which means at least SNV bridge. But if you are bidding for all possible x86s, you kind of have to account for all cases.
When I left, we were already at boot up time on the VM asking which specific model, and we had specifically for memcopy, we had breakdowns that varied by x86 model number and would do things like prefetch if that was a sensible thing for that model number. Absolutely. Certainly TXU, Spark, I want to say not Itanium, somebody else, maybe it was Itanium. We prefetched or not in the memcopy according to architecture. So if there was a hardware and it was better than the software, well, then why'd you use the software ops? The software ops could tell something to the hardware, use them. And if your memory bandwidth bound, they were free anyhow.
Also,
See, I'm just-
going back to the question that Bill asked before, nowadays in functional programming languages, compilers, which very often compile for linked lists, you will also use prefetch instruction.
Yeah.
If you can write your linked list unfolded, so you may unfold your linked list implementation by free pointers, but then you have access to the free next pointers, and then you can use this for prefetching the nodes.
Oh, I bet you Scala's not doing that though.
Probably not. It's relatively new.
I have seen garbage collection mixed in with linked list implementations where the expectation was the garbage collector was going to walk the linked list. He would then force the contents, the things to align in memory one after another. He would chase what could be wild, unrelated pointers, but arrange that they were in order. And then the hardware would see the stride you would get from going element to element and count loop trip counts and stride and decide how much to prefetch for you. So you could scan a large linked list with prefetch on the x86 reasonably fast. But that was a lot of handshake going on there.
I looked at more of the code and I dislike it more. So
Well,
this is
you have to sit there and run a reasonable memcopy-ish test on a large corpus and you know, on a large count of different chips, and to discover that these things probably actually have purpose in some variation or other. Somebody cares.
so
It can
I
help you
looked
do
at
better.
go ahead, Aaron.
Is that Aaron?
Or I thought it was Aaron.
He's muted at the moment. Go, Levo.
Okay, so I think it was prefetch to local cache. I think I looked at that function. It basically did a built-in underscore prefetch and with a locality of 3. And I looked up what that intrinsic does or what that built-in does. And it says it'll, if it's 0, it's streaming. If it's a higher number, it's like the cache layer.
Uh-huh.
So I would imagine you would want to do streaming with a mem copy, but it caches it. It says 3.
Aaron's pointing out that prefetchers have another purpose. They can help you get to speculation bugs, or I guess, you know,
Yes.
Spectre or meltdown style attacks. Yes, exactly.
The M1 or the M1 and the M2 bugs were very interesting. Basically, it had nothing to do with speculation, and just having the data into your in the memory would cause things to load.
Yeah.
And it was a very interesting it's not like a variance because there's no speculation, but it was like a very interesting memory loading problem that was specific to the Apple.
Yeah. Well, fine. I think there's a lot of, we haven't yet figured out what the right answer for that one is.
Yeah.
There's a lot of grief. You slow everyone down, or you cut down sharing some other way to prevent people from having to, you know, I'm not going to share my CPU with
my
you.
bad memory for a too long didn't read version of it is when you have a 64 bits pointer that has the high 32 bits the same as something else that you access.
Yeah.
The chip will assume that since the both high bit is the same, that it's a pointer, and that you want to load that pointer. So it does a prefetch on that.
Sure.
So if you're doing and there was an example of some cryptographic function where it put data into the line, but they weren't pointers. They were just it was just data.
Just data.
But since the high 32 bits were both the same, it thought that, or it was in the same address space as the executing program. I forget what it was, but it preloaded it, and then that led to some speculation bugs. Or some kind of bug with memory.
Yeah. Excuse me. My caffeine here.
This prefetching to cache here is on purpose, of course, because you want this to be on the cache so you can access this in the future iteration that is going to go through this. So no, you would not use streaming here. That would defeat the purpose of prefetching.
Oh, we're streaming
ahead. We are doing this prefetching ahead, so you actually want this to stay in the cache when you catch up with this.
I don't know what you mean by streaming then, because of course, right, I'm prefetching a few lines ahead, and then it gets kicked out when it gets kicked out. So it would likely stick around long enough that you would get to use it before it gets kicked out, but I don't know. The Azul hardware cache line 0 obviously could evict a line, but it wouldn't have to load anything. I was trying to think, would you could force an eviction by running cache line 0s to throw somebody out early.
By the way, streaming loads are evicted very, very quickly compared to like normal
Okay.
prefetch.
Because like there's
So-
there's usually like an LRU-ish like thing going on. Boy, people have a bunch of folks having trouble staying connected here. Yeah.
Do you remember where you
Basically,
heard
wait,
that? Because that's
Okay.
interesting. I've never heard that. Do you remember where you caught that?
Are you talking to me?
Yeah, Adrian, go.
Yeah, so basically, I don't know where I read that, but yeah, essentially the prefetching, the streaming load, it uses a bit different paths in the memory controllers and the cache coherency protocols. Like there are many things that don't get like lots of metadata that doesn't get tracked additionally. So I read somewhere, I don't know if it was in the manual, but streaming like cache lines that are placed into cache with the streaming load are evicted on the first conflict, so they have priority. They get evicted super fast, and they also don't get sometimes placed into the victim cache and stuff like that. Yeah, so yeah, you have to process them as fast as possible.
Yeah.
Right.
Okay. Yeah, I figured, maybe they'd fiddle the LRU count so that it would max it out right away. But instead you're saying they have some extra bits in there. And the bits say it's a streaming, so toss it and don't put it in the victim on the way out and all that kind of stuff. Which
Yeah,
makes sense. It just seems like a heavier weight cache implementation, but
no, actually it's a lower weight, like so basically
well,
something
it
that
causes you some extra bits to be tracked in the cache.
no. Less bits get tracked for the streaming loads. So like for normal cache lines get yeah.
I think Cliff,
Over other cache designs I've looked at, the overall every line is tracking more stuff. And then if you're streaming, you don't need to set all those bits, or you're not setting all those bits. But if you're not streaming, you're also tracking, I'm not streaming and I'm LRU of this and that, and maybe something else. There's some extra bits in the cache line implementation to say this guy is not streaming, he LRU counts himself down. This guy is streaming, he goes out faster.
Right. Yes, exactly like that.
Okay. And then something else in there about victim cache went one way and something else about coherency protocols changing, which maybe if you're streaming for doing these 64 bytes or 128 or 256 bytes at a shot, and you have overlapped updates or writes from other people, and maybe they go to a weaker memory model. And
yes, so yeah, in the case of a streaming store, for instance, like I actually had to implement some very massive mem copies, and the normal stores were not enough because they were cache coherent. But with streaming stores, they're not, and you can get great efficiency gains with this. So what you do is you just streaming store like all your massive gigabytes of memory, and at the end you throw in an S fence in there, and then should be fine.
And you're fine. Yeah. Okay. So he just cheated his way along the whole time.
Yeah.
Yeah, which is fine. I mean, everyone knows what the rules going on, and then you're good. All right. We got anything else here? I'm looking at a wind it down here unless somebody else got another topic. We've all about streaming memory, and it's actually been entertaining for that, and looking at pushes and pops and everything else. No one tracking in the timestamps at all. Who knows when we started about memcopy?
I could shortly demo the thing I was working on with this interactive compilation thingy with my compiler.
Go for it.
I posted a little GIF into the Discord, but I can share it here.
Okay, you should have sharing. Go. I'm trying to write something into the document, and that we're like 2 hours late here.
Yeah, can you guys see my screen?
Yeah. Yeah.
Okay. All right. So basically, so I have this compiler and I have this watch mode, and it uses file watching. So if I now compile this, I get an overview, like a live overview of my virtual registers, intervals, and like the LLIR. So my low-level intermediate representation. And so I can start programming and can do stuff that doesn't affect anything, or I can like do an add, and then I see here new things pop up. And this is not particularly optimized. There's many things missing here, but I use this for debugging my optimizer. So I can.
So you're putting up
like-
color bricks to show lifetime
Yes.
intervals colored. And is that a VI or an Emacs?
That's
Yeah.
it's called Helix or something. But nice thing is it's very interactive and very fast. So if I'm missing a semicolon or something, it will tell me, and it compiles everything from scratch very quickly. So yeah, and I also did the same test on a large file that is 200,000 lines of code. You also get instant feedback. It does from scratch builds and shows you the entire tree. So yeah, that's pretty nice. And if I turn this into a for loop, then I get different things.
The file watcher, huh? Yeah, I might have to screw around with this.
It's pretty nice. It's a bit limited because, I mean, screen space is limited. If the function gets big, yeah, it's kind of annoying. But it's pretty useful for testing out, like doing like explorative debugging. Because a lot of times I need to do minor changes and see how that influences the optimizer, or maybe I have a parser bug or something like that. So yeah, kind of a different flow of debugging. So yeah.
Times past, I would have a GDB session inside Emacs, and I would do a print and get that rolled out in the same buffer that I could inspect immediately and edit, compile, search, fold, stable, mutilate, and then go again, but not in a separate window and not with the little bit of ASCII art graphics, which really stood out. Like that looked good.
Yeah, it looks pretty. Yeah, thanks.
Some ASCII art graphics. Like simple, I dump an IR dump out all the time, and it's regional ASCII art kind of. But to put it on a file watch and a separate buffer, I should have done that long ago. That would be very helpful.
Yeah, the thing is, there's something. Yeah, I do feel like sometimes I kind of need multiple buffers that display different things at the same time, maybe even while the code is running as well, and plus the debugger. Like, yeah, I don't know. I feel like the tool, there's some opportunities for like hacking on better tooling there.
There's a tooling thing, yeah. Better tooling for compiler writers.
Yeah, but I mostly, basically I just implemented this for my own purposes for explorative debugging. And essentially I get something similar to Godbolt once I include the assembly in there.
Yeah, right.
Which is nice. I mean, it's crazy how much more productive forum discussions around compilers and performance have become since Godbolt became very standard, because people don't need to speculate about what the compiler does or does not inline or do here and there.
Yeah.
So I feel like knowledge sharing has become better, and this interactiveness and the feedback is really very useful.
Yes. And then you can do shit like, holy crap, what the hell is this compiler doing with all these pushes and pops here? What a fucking crazy bad compiler it is. And then some feedback gets back to the compiler writer. You're right, Sherlock.
Or it becomes content for CCC.
There you go. All right. Anything else? I'm going to wind it down.
So Adrian, which compiler are you working on? Is it a larger project? Is this your own thing?
Yeah, it's my own compiler for my own language. Yeah.
Aaron, you have a special problem. Aaron's putting in the chat. This is a Twitter, Facebook, Google-ish, anybody doing social media. I have 200,000 servers. They have 200,000 performance counters from VMs I've been running for days and years on end. I would love to gather them all up and use them to start the profiling or be the profile seed for the next time I start a server up. And honestly, Arthur's not here, but that's his, I won't say reason to enter it. It's one of those main goals is to say, yes, I know that one too. The main goals is to say, I have this profile data so I can start up a new VM using both profiles that I've collected from before. You just happen to have a situation where you want to collect a lot of profiles from a lot of servers. I'd talk to Arthur and see if there's a way to get him to cough out his profiles, have you gather them, fold them together, and then I know he can feed them back in too.
There are all
There's
these
things there.
slightly annoying IT monitoring things like Splunk that are designed to capture, you know, outputs from 100,000 machines and aggregate them and stuff. I hate them, but I don't know of anything better.
Exactly.
I assume these people have been thinking about this type of how do you gather information from all these machines for a while.
Mm-hmm. Histograms add nicely. Yes, they do. There should be a way to do this. Splunk will probably happily take your money to do that if you can VM to cough it out. And I swear Arthur has a way to cough those data out. So I think you're halfway there if you go talk to some different JVM. All right. Now I'm going to be done. All right, folks. It was good talking. Fun round trip through memcopy land and other places. And until we meet again. Right. Bye.